Whether you are a computer science student or a software engineer, I'm sure that you've heard the term thread or process. In this video, I will explain the two in a simplified way. Here we have some common programs, for example Chrome, Adobe Photoshop, and Discord. The operating system will wrap each program in a process. It means that Chrome will have its own process, and also Adobe Photoshop, and also Discord. And each process is completely isolated from another. It means that Chrome cannot natively speak to Discord or Photoshop because that Chrome doesn't share the same memory region as those two. So because that the operating system will give each process its own isolated memory, processes cannot natively communicate or share data between each other. Let's take a look inside of a process. So in each process, we will have at least one thread. So a thread is an execution unit which will exist within a process inside of a process. So here we have one thread, and threads, due to the fact that they share the memory of their parent is a process, they can natively share data between each other without any problems. And soon we will see it practically in code. Threads within the same process can easily communicate with each other due to the fact that they share the same region of memory. Let's create a program which will use a couple of threads, and you will see that each thread can communicate with each other without any problems. So the first thing we are going to make is an array called results, and each thread will append its result into this array. Let's create a function which will take a number as a parameter and will append it into our results array. And each thread will call this function. So we can call results append and append our number. Let's iterate over a range of numbers. So we can do this for in range, and we will create a thread for each iteration. So I can use the threading API. I have another video about it on my channel, so you can take a look. And we should call our function. So this is our test function. Here we should specify arguments. And of course, let's specify our value, which is this. And we should start the thread, of course. Thread start. Here I will create an array which will hold all the threads, and I will append each thread to this array. Threads append thread. Now I should call the join method, which will iterate over each thread and call the join method. We do it in order to make sure that all the threads have finished correctly before that we proceed with our program. So let's do it for thread in threads, and we can call the join method. Let's print the results and then run our program. And as you can see, based off this output, all the threads were able to successfully access this location. And it is because that they share the same region of memory of their parent, so it is not a problem for them to access this results array and append data into it. Each process will have its own process ID as well, so we can print it so that you can see that all the threads share the same one. So we can do print get PID, which will give us the process ID. And also we should print the number. Let's run it. And as you can see, all the threads share the same exact process ID. It means that they belong to the same process. And also let's print the results again. So here are the final results. All the threads were managed to successfully insert data into this shared region of memory or shared data structure, which is the results array. And now let's try to use processes instead of threads. So I will make our code suitable for multiprocessing API. So let's do it. If name equals main, Now I will nest our code inside of this and take a look at the output now. As you can see, each process has a completely different process ID. And take a look here, we got an empty array. It is because that those processes do not share the same region of memory, and it means that they couldn't write to the same location, because that this process has its own memory, and also this one has a completely different region of memory. And that's why here we see an empty array.